So yes, a single line represents 2 electrons. And in the Lewis structures, you notice here with HH, there are no more electrons that are just free and floating, okay? Because each of these H's here has 1 valence electron. So each of those individuals come together to form a bond. But in chlorine, each chlorine only needs 1 electron. So they borrow 1 from each other, and we connect them with a line. But we still have 6 other valence electrons that are non-bonded. So we have to continue to represent those non-bonded electrons with the dots, okay? So let's talk about the easiest steps to forming Lewis structures of compounds. Okay, first, you want to find the sum of the valence electrons of all the atoms in the molecule or polyatomic ion, okay? Now, regarding polyatomic ions, these 2 bullet points are important as well. If it's an anion, meaning a negative polyatomic ion, you must add 1 electron for each negative charge. So if it's a polyatomic ion that has a -3 charge, you have to add how many electrons? 3, very good. And it's just the opposite if you have a cation or a positive polyatomic ion. You have to subtract 1 electron for each positive charge. So if it's a polyatomic ion that has a +1, how many electrons are you going to remove or subtract? Uno. Okay? So we're going to be using this example throughout these steps. PCl3. All right? So looking at the periodic table, phosphorus is right here. And what group is it in? What group is phosphorus in? Right there. 5. Therefore, it has how many valence electrons? 5. Very good. So, as you see here, keeping track here, you have 5. Next, we have chlorine. And how many chlorines do we have in this molecule? 3. Very good. And so, we have to keep that in mind when we add the sum, because a single chlorine has 7 valence electrons. Well, since we have 3 chlorines, we have to multiply 3 times 7. And then once we do that, we have to add the 5 from phosphorus. And we have a grand total of 26 valence electrons in this whole structure that we have to keep track of. Okay? So after you found the sum, we go on step 2. We use the trends or the notion of electronegativity. So the central atom, since we have multiple atoms, or we have more than 2 atoms coming together, we have to identify who will be the central player here. And that central player will be the one that is least electronegative out of all the elements present. Okay? So, using the trends of electronegativity, phosphorus and chlorine are in the same row. And the trend for the electronegativity in a row is going from left to right. Electronegativity increases. So that is why phosphorus is the central atom in this example. Okay? It is less electronegative than chlorine, so it gets plopped in the center. Once you determine that, you then connect all the atoms involved with a single line. Always start off with a single bond. Okay? And so, phosphorus goes to this chlorine, this chlorine, this chlorine. By using 3 single bonds, how many electrons did I just use? If each line represents 2, how many did I just use? 6. Mental math morning. Don't you love it? So, we use 6 of the 26 valence electrons. So again, keeping track, 26 minus 6, we have 20 left to go and deal with. Okay? Now, step 3 says, place electrons on the outer elements first. Fill their octets. Okay? So that means we got to place 6 around each of the outer chlorines. And so we use 18 of those remaining 20 valence electrons to fill the octets of the chlorines, which leaves us with 2 valence electrons remaining. Once we have filled the octets of the outer elements, we then fill in the octet of the central atom. So we take those 2 that remained, place them on phosphorus, and then we step back and take a look at our final structure. Does every one of these elements have an octet? And if your answer is yes, well, then you're good. And then you can move on to the next one. Okay? So, we've already done this example. Let's do a practice exercise here. Okay? All right. So, on the practice exercise right here, it says how many valence electrons should appear in the Lewis structure of CH2Cl2. So I'm just going to do this on my whiteboard here. Okay. And then I go here. If I can get it straightened up. And I'll zoom in. All right. So we need to find the sum of all of these elements and their valence electrons. How many valence electrons does carbon have? Anybody? 4. Okay. Now, how many does a single hydrogen have? It has 1. How many are present, though? 2. So how many valence electrons are going to be contributed by all hydrogens? 2. Excuse me. And so now we have chlorine. We've already established that chlorine has 7 for a single atom, but we have 2 present. So we have 14 valence electrons from chlorine. And then we sum them up, 4 plus 2 plus 14, we get 20 valence electrons. Now, one thing that I kind of read over, and I didn't mean to, is this, okay? Talking about which one's going to be the central atom. It's the least electronegative that isn't hydrogen. So hydrogen will never be a central atom. Okay, so keep that in mind. I wanted to go back to that since we have hydrogen present in here. So next, going back to our question here. It says now that we've established the number of valence electrons, we need to draw the Lewis structure. Okay. All right. So, because we're not going to be looking at hydrogen as a central atom. Let's see, where am I? What example is this? 3.6. Okay, yeah, that's what I thought. So we have to look at carbon and chlorine. Between those two, who would be a central atom? Carbon! Very good. So carbon, being less electronegative than chlorine, is going to be a central atom. Okay? Now, for our outer elements, we have 2 hydrogens and 2 chlorines. And so we need to figure out a way to put this on here. And again, it kind of goes back to make it symmetrical. Okay? You could put 2 hydrogens on the sides and 2 chlorines on the tops, or you could do the other way, 2 hydrogens on the top and bottom, or 2 chlorines on the sides. Doesn't really matter, but I'm going to go ahead and connect my hydrogens on top and bottom, and then connect my chlorines on the left. Okay. Now, before I go on to the next step, I need to keep track of my electrons. How many valence electrons did I just utilize to make my connections? I used 4 single bonds. So how many did I just use? 8. So 20 minus 8 means I have 12 valence electrons I need to deal with. So then I go to the next step and proceed to place them and fill the octets of the outer elements. Do I need to place any on the hydrogens? No, it's already filled. It's got its 2. Remember, hydrogen and helium, they like 2, but mostly we deal with hydrogen. So then I shift my attention to the chlorines. And if I cover this up, this chlorine already has 2. So I have to place 6 around that chlorine and 6 around that chlorine. How many did I just use? 12. So minus 12, which leaves me with 0. So I've utilized all the ones that I have, and I take a step back and I say, does everything on here have a full octet or a full outer shell? Carbon, if we just count these, 2, 4, 6, 8, it's happy. This chlorine has got 8. This chlorine has 8, so they're both happy. And each hydrogen has 2, which makes it happy. So we all good? Exactly. So this would be what your Lewis structure for CH2Cl2 would be. Okay? Questions on that? All right. Well, as you can imagine, we're going to be stepping it up a notch every example we get. And I might not, just putting this out there, I might not get to everything I want to today for this section. It's kind of a long section. So if I don't, I'll make adjustments to the schedule and it'll just be what it is, okay? But in order to keep my plan for the remaining year, which I've done, there will probably be a video on Monday. Kind of doesn't happen very often, but there most likely will be, okay? But let's say after we've put all of our valence electrons out there, and we still have a situation to where we don't have complete octets. So if we run out of electrons before the central atom has an octet, we then have to go and form multiple bonds. So as you see here, with cyanic acid, the formula for cyanic acid, or cyanic acid, we have the Lewis structure where we followed all the first 4 steps. But yet carbon does not have a full octet. So we then have to begin borrowing some valence electrons where we can. And so what we can do is we can borrow this set of 2 from nitrogen and this set of 2 from nitrogen. And we use those to bond carbon and nitrogen together. And we get this final version here on the bottom where we have a triple bond between carbon and nitrogen. Okay? And then once we do that, we take a step back and we see that everybody still has a full octet now. Okay? So that's why you take a step back after step 4. You count and see, does everybody have an octet, especially the central atom? If not, we got to look at making multiple bonds. So let's do a couple of Lewis structures here. Let's look at NO+, so our first polyatomic ion. Okay? So first, how many valence electrons does nitrogen have? It's in group 5, so it has 5 valence electrons. How many does oxygen have? It is in group 6, therefore it has 6 electrons, or valence electrons, I should say. But we've got that. We have a plus sign. So when we have a plus sign, that means we have to remove electrons for each charge. Well, how many charges or positive charges are on this ion? 1. So we have to remove 1, which gives us a grand total of 10 valence electrons. So let's start drawing the Lewis structure. Okay? There's only 2 atoms here, so we don't have to worry about who's going to be central. So we just bond it with a single line, starting off. So how many did I just use there? I used 2 to bond them. I have 8 remaining. Okay? So, excuse me. What we can do now is follow the same steps. We can place the remaining valence electrons on the outer or on the elements here. As you notice, we have 8 remaining. So really what we could do is we can split them up evenly. Okay? We could put 2 here, 2 here on oxygen, 2 here, 2 here on nitrogen. So I just used my remaining 8 valence electrons. But does everybody have a full octet? No, they don't. Okay, so what we're going to do is start creating multiple bonds. We're going to borrow some electrons to help do this from each one. So I'm going to take one from here, one from here. They're going to come join together. So now I'm going to get what looks like this. A double bond between nitrogen and oxygen. And I still have to indicate how many I have present. Okay? If I cover up that nitrogen, how many do I have for oxygen? I've got 2, 4, 5, 6, 7. Okay, let's count my other one here. 2, 4, 5, 6, 7. Neither one has an octet, right? So if I still don't have an octet present, I have to continue to borrow. Take that one, take that one. They come up here. And now I have formed a triple bond. Okay? And I'm just going to put my remaining 2. Again, I like symmetry. Okay? I like symmetry. So take a step back and now count. How many do I have on this oxygen now? 8. What about nitrogen? 8 as well. Because again, each line is 2. So 2, 4, 6, and 8. So I'm happy. But this is your heads up on this. This is a polyatomic ion. In order to have a finalized polyatomic ion Lewis structure, there's one more step you have to do. And that is you have to place them in brackets, and in the upper right-hand corner, place the charge. If you do not place the brackets and or the charge on the outside upper right corner, it is not a complete Lewis structure for a polyatomic ion. These are a must. Okay? Excuse me. There is a second example given to us by the book. And that is C2H4. Okay. So again, first step, calculate the number of valence electrons. Carbon has 4 for a single, but there are 2 present, so we have 8. And hydrogen, again, a single one has 1, but there are 4 present, so that's 4. And so that gives us a total of 12. All right, so now we've got to find the Lewis structure. Now here we have kind of an interesting situation. We only have carbon and hydrogen, okay? And so we know that hydrogen can't be the central atom, but we have 2 carbons present, which are obviously the same element. So here's how we do this one. We connect carbons together. And again, keeping track, we just use 2. So that means we have 10 valence electrons remaining. But we still have to deal with the 4 hydrogens. So again, symmetry here, I'm going to connect those 4 hydrogens, 2 for each carbon. Okay. I just used 2, 4, 6, 8 of my remaining valence electrons. So keeping track means I have 2 left. I can't put any more on the outside elements, the hydrogens. So again, splitting them up evenly. I'm going to put 1 there on that carbon, 1 there on that carbon. I just put them there for ease of our next step. Okay? If I cover up this side and I look at carbon, since it's one of my central atoms, and I count how many valence electrons it has, I find that I have 2, 4, 6, 7 electrons on that carbon, and then 2, 4, 6, 7 on that carbon. Neither one has a full octet yet. So following step number 5, I have to begin forming multiple bonds. So I'm going to take this electron, come down here, take that electron, come down there. I then get a new structure that looks like this. A double bond between those carbons, and my hydrogens out here. Again, taking a step back, see how many are on each. 2, 4, 6, 8. That carbon's happy. And then 2, 4, 6, 8. That carbon's happy. Everyone's happy so far. And then before I put my stamp of approval on here, I go and double check what I was given. Do I have a polyatomic ion here? No, I don't. So I don't need brackets. This would be my answer. Okay? Questions on multiple bonds, polyatomic ions, regular Lewis structures? Okay. Now, if I remember correctly, oh yeah, let's do a couple more ions here. So what we'll do is this. And we've got 5 minutes. Let's do our first practice exercise and see where we're at in terms of time. And then we'll discuss what's next. Okay. Let's look at practice exercise A, ClO2 minus 1 charge. Okay. Excuse me. So here's a formula that we have to draw a Lewis structure for. Chlorine has 7 valence electrons. Oxygen has 6, but there are 2 present. So 6 times 2 is 12. But then you see this minus 1 here. And I have a minus. What does that mean I have to do with my number of electrons? I have to add for each charge. And since there's only a minus 1, I add 1 electron, which gives me a total of how many? 20. Very good. Excuse me. All right. So now we begin doing Lewis structure. But we have to identify who my central atom is. If you look at the periodic table, I hate allergies. You see that chlorine and oxygen are catty-corner from each other. Oxygen is above chlorine, but to the left of chlorine. So just using the trend is a little too difficult to use. So then we use that chart that I gave you the other day with the values. And if you look at that chart, you would see that chlorine is actually less electronegative than oxygen. So chlorine gets my central atom position. Okay? So I just used 4 of my 20 valence electrons. So I have 16. So now my next step is I fill the octets of my outer elements. So for 6 on the oxygen, 2, 4, 6 on that oxygen. And so I just used 6 plus 6 is 12, which leaves me with 4. Where do these remaining 4 go? They go on that central chlorine atom. Now, take a step back. Does every element, especially the center, have an octet? Yes, it does. Am I finished with this one? What do I have to do? Put it in brackets and include the charge. Okay? So yeah, we will not get as far as I thought, which I think in the back of my mind, I knew we weren't going to get finished with this section. So I had originally intended for you to work overnight on some Lewis structures, but I'm going to wait until we get through this entire section tomorrow to give that to you, okay? So fully expect that on Monday to have a video covering the next couple sections just to keep on track with everything, okay? So good work. We'll continue this tomorrow.